This is a video that's going to summarize the important points of Chapter 3, because we are telling a story here, and we want to be sure to follow this story through. What we're trying to do, remember, is to be able to predict exchange rates. And remember that exchange rates, there should be a model for exchange rates. There should be a model that helps us to understand, first of all, why they are what they are currently and why they change over time. What are the variables, or what are the circumstances under which they change? What impacts them? These are the kinds of questions we want to be able to answer. And of course, once we do answer them, what we would expect is a general model that explains exchange rates. And this model will come in the form of an equation. But don't worry, we'll do it carefully and slowly so that you'll see how this equation should operate. So let's begin. There's going to be two different approaches to this. First of all, we're going to try to understand the purchasing power of currencies in different countries. That is, we're going to try to answer the question why, or if they do, why do products or goods cost more or less, or even the same, in one nation as they might in another? One might expect that the cost should be relatively the same once you take into account transportation costs and other minor frictions that might exist in delivering goods to the various nations. And then what we're going to do is we're going to try to relate the exchange rate to price levels in the various countries. And of course, price levels are related to monetary policy conditions in each country. So we'll try to relate the monetary policy to the price level, and once we understand the price levels in the two countries, we'll try to then relate that back into the exchange rate. So together, this is going to allow us to develop a long-run theory known as the monetary approach to exchange rates. So we begin this analysis with the idea of purchasing power parity, but we start with the law of one price. That's usually called LOOP, or loop, and it applies to just a single good, one particular good, say a Toyota Tundra. And what we're going to argue here is that through arbitrage, prices in different countries in a common currency tend to equalize. And what that means is that if a Toyota Tundra costs a certain amount in the United States, according to the US dollar, if I were to translate that Toyota Tundra into the euro, I would expect, according to the exchange rates, for the price to be the exact same. But that's only for one good. What we're also going to find is that if I were to take a basket of goods, then the law of one price is called purchasing power parity. That is, that basket of goods in the United States ought to cost the same amount, according to purchasing power parity, in the euro when consumers purchase that basket in the euro countries. So the law of one price applies to just a single good. Purchasing power parity implies the entire basket of goods. So then what we're going to argue is that a simple theory based on frictionless trade that doesn't have any kind of transaction costs, that we can then develop an entire theory of exchange rates based on purchasing power parity and the law of one price. So let's start with the law of one price and just explain this in terms of an equation. So let's take a look at the law of one price for just a single good that's both sold in Europe and sold in the United States. And let's consider the relative price of the good in the United States and in Europe. And let's take the ratio of the two. Now, if I were to take the ratio of the price of good G in Europe and divide it by the price of the good in the United States, if the law of one price really holds, I would expect the relative price to equal 1, right? Because we would expect that once you translate the good that's being sold in Europe and you translate it into dollars, if the law of one price holds, I would expect it to be exactly the same as the price of the good that's being sold in the United States. So let's let Q equal this relative price, and let's hope that it equals 1. So how do we translate it? Well, let's take a close look. We're going to let Q equal, and here what we're going to do is we're going to take the European price of good G and we're going to put it in terms of the United States dollar. To do that, we have to multiply the price of this good in euros and multiply it times the exchange rate. Now, I'm going to point something out here just so that you students that aren't that good or nifty in math, if you will, notice how these units cancel out. Students often get confused when trying to figure out whether you divide the exchange rate or whether you multiply the exchange rate towards the price in order to translate it into the price of another nation's currency. Well, notice here that I have the price in euros. In order for me to end out with dollars, I have to make sure that the euro in the exchange rate is in the denominator. If the euro in the exchange rate is in the denominator, then it'll cancel with the price. When I multiply the price of the good in the euros, the euro value will then, the euro in units will then cancel out, and all I'll be left with is the dollar. So this exchange rate, we're multiplying times the price of the good in euros. And what we're going to end out with is the price of that good in dollars as it's being sold in Europe. And I divide that by this exact same price of the good that's being sold in the United States. If the law of one price holds, I'm going to expect this to equal 1. Now, all I'm going to do here is just do a little quick trick, so to speak. I'm just going to rearrange these. This is simple algebra. I'm simply going to divide out the price of the good in Europe. So I divide both sides of the equation by PG in euros, and what I end out with is an exchange rate of dollars per euro. And it should be equal to the ratio of the prices of the goods. So here we begin to have an understanding of what the exchange rate of a particular good so far should equal. It should equal the ratio of the prices in the two countries. So the exchange rate equals the ratio of the goods prices expressed in the two currencies. Okay? So we're beginning to understand where exchange rate comes from, at least when we're talking about one specific good. So now let's apply this theory to a general basket of goods. Remember, when we take the law of one price and start talking about a basket of goods, we're now talking about purchasing power parity. This is at the macroeconomic level. If I talk about loop or the law of one price, I'm still at the microeconomic level. So now let's express this law of one price or purchasing power parity in the aggregate. And algebraically, it's exactly the same, but now we're just talking about a basket of goods. And once again, I take the basket of goods in Europe and I translate it into dollars by multiplying it times the exchange rate. And then I divide that by the basket or the price of the basket of goods expressed in dollars of the good when it's purchased in the United States. And we're letting that equal Q. Now, again, I expect Q to equal 1 if the purchasing power parity holds, or if loop holds, right? And if it is equal to 1, then I ought to be able to rearrange this equation and multiply both sides of the equation by the price of the good in United States dollars, or even solve for the exchange rate. So again, once there's no arbitrage opportunities that exist, then what we would expect is that the price of the basket should be the same in both locations, implying that Q should equal 1. So purchasing power parity holds when the price levels in two countries are equal, when expressed in a common currency, right? So what we do have to do is to take that basket of goods and put it into the same currency of the basket of goods you're comparing it to. Here, we're comparing it to the price of a basket in the United States, which is in dollars. So we take the euro basket, which is in euros, multiply it times the exchange rate to get it into United States dollars, and we would expect that this ratio should be the same. That is, the ratio should equal 1. Okay, we call this absolute purchasing power parity. That is, absolute purchasing power parity implies that Q is equal to 1. So here's a quick example. We have a European basket, it costs 100 euros. And we have the exchange rate of dollars per euro of $1.20 per euro. So notice euro is in the denominator. Dollars is in the numerator. Now, for purchasing power parity to hold, the United States basket would have to cost 1.2 times 100, which is $120, right? I'm multiplying 1.2 of the exchange rate, which is dollars per euro, times 100 euros. Notice the euro is in the denominator in 1.2. It's in the numerator when I'm talking about the 100. So the euros cancel. So I end out with $120. So this is the United States basket, what it would cost in the United States. Again, notice that the euro units cancel. Now, here is an important point that you should recognize. We have something that we call real exchange rates and something that we call nominal exchange rates. When someone tells you what an exchange rate is, you're getting the nominal exchange rate because it's telling you the number of dollars per euro or the number of yens per euro. Again, it's giving you a nominal rate. But the real exchange rate doesn't have any units because what we're really talking about is a basket. We're not talking about the exchange rate in terms of currencies. We're talking about the real exchange rate in terms of goods. What goods can we exchange for other goods in these two nations? And how do we know that it's a real exchange rate as opposed to a nominal one? Well, take a look at this equation. What this equation tells us, Q is equal to the exchange rate times the price in euros divided by the price in dollars. Notice all of the units cancel here. Notice that the euro is in the denominator in the exchange rate. I'm multiplying it times a price that's in euros. Those euros cancel. What I'm left with is an exchange rate that's only in dollars times a price that no longer has a units associated with it, and I'm dividing that now by the price in the United States dollars. Again, that's in the denominator, so those units of dollars cancel, and all I'm really left with is a value of E times a price, just the price that was the euro, divided by the price in the United States dollar. But all of the units have canceled, and so notice this is just a number. Q, when we're talking about the real exchange rate of a relative price of baskets, that is, when I'm talking about Q, I'm talking about the real exchange rate, and notice that all of the units cancel, so it's nothing but a real number. And what we're really asking here or saying is that the U.S. baskets, what are the number of U.S. baskets that are needed to purchase one European basket? So again, the exchange rate is a nominal concept. That's what you usually hear when you read the papers or go to the bank to exchange currencies. But the real exchange rate is a goods concept. Think in terms of barter. And this is just a quick review. Remember that the real exchange rate has terminology just like the nominal exchange rate. So remember, when the real exchange rate goes up, that means that the home has experienced a depreciation, a real depreciation. And similarly, if the real exchange rate falls, that means that the home has experienced an appreciation. Notice again, we have an inverse relationship. The exchange rate goes up, that means that home has experienced a depreciation. Okay? Now this will help you in the homework. So purchasing power parity means that the real exchange rate, Q, is equal to 1. And this means that one basket of goods in a home is going to buy exactly one basket of goods in the foreign country. But now if it's not equal to 1, that is if Q is less than 1 or greater than 1, there are a few things we can say. For example, if the real exchange rate Q is less than 1, what we can say then is that the foreign goods are cheap. Home currency is strong and the euro is weak, which implies, of course, that the euro is undervalued. Now, why is this true? Well, remember Q, which is the United States per euro, means that for 1 euro, you're getting less than 1 United States dollar. So for 1 euro, say for example, US is 0.9, 90 cents per euro, then that means that 1 euro is only purchasing 0.9 of the US currency. And so this means that the euro isn't getting 1 for 1. It's getting less than 1 in terms of the United States currency. So this means that the euro is weak and that it's undervalued, whereas the home currency, the United States currency, is strong because it's getting for its 90 cents, a little bit more it's getting a whole euro. So foreign goods are cheap to the United States. Home currency is strong, but the euro is weak because it can't buy as much, and this means that the euro is undervalued. And similarly, if the Q is greater than 1, then this means that foreign goods are relatively expensive. Now, again, remember that when Q is equal to 1 and absolute purchasing power parity holds, we call that the no arbitrage condition or equation, because when they are the same across nations, no one can really gain any advantage profit-wise by exchanging goods between the two countries. Their purchasing power parity holds, and so we call that an equilibrium position, and it implies a no arbitrage equation. So we can rearrange this arbitrage equation when Q is equal to 1 and, solve for one variable over the other. And in this case, we've simply multiplied both sides of the equation when Q is equal to 1, the no arbitrage equation, and we multiplied it times the price of the good in US dollars. And what this gives us, of course, is this allows us to solve for the exchange rate that would be implied when absolute purchasing power parity holds. That is, when the no arbitrage condition holds. So continuing and solving for the exchange rate, now what we find is that the ratio of the price levels in the two countries is equal to the exchange rate. So purchasing power parity implies that the exchange rate at which two currencies trade equals the relative price levels in the two countries. This is an important concept. I'm going to say it again. In the no arbitrage condition, when absolute purchasing power parity holds, we can solve for the exchange rate. And we find that when purchasing power parity does hold in the no arbitrage condition, we know that the exchange rate is going to be equal to the ratio of the price levels in the two countries. So this is going to help us understand what might happen when inflation exists in one country and doesn't in the other. Continuing on, let's be sure we understand this. Absolute purchasing power parity, when it holds, meaning, of course, that the no arbitrage condition in equilibrium holds, means that if a basket of goods costs $460 in US and the same basket costs $400 in Europe, then purchasing power parity predicts an exchange rate of $1.15 per euro. Now, this is what the exchange rate had better be, because we're expecting absolute purchasing power parity to hold, and we're expecting that in the long run that no arbitrage conditions should exist. And so it ought to be the case then that the ratio of the price levels really do equal the exchange rate, because this exchange rate then will bring the Q back to equal 1. So again, purchasing power parity predicts that the exchange rate had better be equal to $1.15 per euro. Okay, we got ourselves a model. What we've just said now is that if I know what the price level is at home, and I know what the price level is in the foreign country, I get to know what the exchange rate is. The input of the model are known variables, exogenous. They're the price levels in the two countries. And I have an output, and this output now tells me what I should expect the exchange rate to be. This is an economic model, a simple one, granted, but it is an economic model, and notice it comes in the form of an equation, this equation. So notice most economic models can be expressed in terms of an equation. Got it? Now we're going to move on to a very important idea. We're going to show how inflation impacts the exchange rate. Now, it shouldn't be that very far of a step, because we now have price levels showing how the price levels impact the exchange rate. But a price level isn't the exact same thing as inflation, because remember, inflation is a growth concept, but prices is a level concept. If you're familiar with calculus, inflation would be the first derivative. It's telling you how the rate of change is experienced in the price level. So if the price level begins to change, we can calculate that rate of change, and we call that rate of change inflation. So we're going to analyze this. We're going to take the rate of change of this ratio, and we're going to ask what the impact of that rate of change might be on the exchange rate. So this is what we mean by analyzing the inflation rate on the exchange rate. Let's keep moving. So all we're going to do is we're going to take this purchasing power parity equation where we have the exchange rate equaling the ratio of prices. And the first thing we're going to do is we're going to analyze what the rate of change of the exchange rate is. And we're going to use just simple algebra. We won't use calculus. We're just going to use the delta to represent the rate of change. And we're going to do it at time t. That's what the t stands for. So we're going to analyze the rate of change at time t. And what that really means is that we're going to take some point in the future, say t plus 1, at time t plus 1, and we're going to subtract that from the current exchange rate at time t, and of course divide it by that rate of at the exchange rate at time t, and this will give us the rate of change. Now we're going to do the exact same thing to the other side of the equation. We're going to examine the rate of change of the ratio of the price levels. So let's take a close look at that. Notice I have delta, or the rate of change of the price level. The price in US divided by the price in euros. And I can really just analyze this. We won't go into the details. We can prove this with calculus. But when I take the rate of change of a ratio, I can actually just simplify that and take the rate of change of the US price and subtract that from the rate of change of the euro price. And we're just going to assume this because it's provable through calculus, but I don't want to go through the proof, and I don't want students to have calculus in order to take this course. So notice that all I'm doing here is coming up with an equation that helps us understand how we can calculate the rate of change of the ratio of the price levels. And what I'm going to say is that the rate of change is nothing more than the change in the United States price level minus the rate of change of the euro. Again, notice we're doing it at time t. So what I've done here is I've taken the rate of change of prices at time t, and I'm subtracting that from the rate of change of the euro prices at time t. Again, delta p divided by p in dollars is just the rate of change in the United States of prices. Remember, this is just inflation. That's all we mean by this. The rate of change of prices is nothing more than the word we use for inflation. By definition, inflation is the rate of change of the price level. So we can actually take this rate of change of the United States dollar and the rate of change of the price level, in euros, and we can just assume then that that's just nothing more than inflation. Now, I should tell people that in economics, pi always represents inflation. It represents a growth rate. So in whenever you see pi, know that in economics, we're talking about inflation. So we're using the term pi in United States dollars to mean the inflation rate in the United States, and we're going to subtract that from the inflation rate in the euro. What have we just done here? All we've done is shown that the rate of change of the ratio of the price levels in the two countries is nothing more than the difference in the rate of inflation in the two countries. Okay, next. Let's do a quick example just to make this a little more firm in your brain. If I have a price level today that's, let's say, 100, and 1 year from now it's 103.5, then the rate of inflation is 3.5 per year, right? It's 103.5 divided by 100. It's 103.5 minus 100, all divided by 100. And this is nothing more than 3.5% per year. Okay, we now have a brand new, very powerful equation. Look at this. If the equation for levels of exchange rates and prices hold, then it has to also hold for the rates of change in these variables. So I'm going to combine the last two expressions that we just analyzed. We just analyzed the rate of depreciation of the nominal exchange rate by calculating delta E divided by E, and what we found was that this is nothing more than the rate of the inflation differentials. If I subtract inflation at time t in the United States minus inflation in Europe at time t, I ought to get the rate of change of the exchange rates. That is, the rate of depreciation of the nominal exchange rate. So relative PPP means that the rate of depreciation of the nominal exchange rate equals the difference between the inflation rates of two countries. Now we have two very important concepts. We talked about absolute purchasing power parity, which equaled Q, which implied that if absolute purchasing power parity held, Q equaled 1. But now we're talking about a relative purchasing power parity, and that means we're talking about the rate of depreciation or the rate of change of the exchange rate, of the nominal exchange rate. And what does relative purchasing power parity imply? Well, it implies that the rate of depreciation of the nominal exchange rate is nothing more than the inflation differentials at time t in the two countries. Very important concept. Now, I bring this graph in for a very important reason. We're talking about the long run model for exchange rates. And that's important because the next chapter is going to talk about the short run. Why do we even draw this distinction? Well, take a look at this graph. Does this look like a graph where the short run exchange rate does really equal the price levels? Look at the short run. Look how much change the exchange rate. Look at the volatility in this thing. You get massive changes in the exchange rate in the short run. Notice it goes in the red, the exchange rate goes way up and then way down in 1985 and comes back up again. But look what's happening in the long run. We allowed the exchange rate to begin to float in about 1974 when the capital accounts were opened, and in 1972 when we went off the gold standard. So when the capital accounts were opened up and we allowed money to flow freely across nations, in the very beginning, in the short run, what we found was that the exchange rate really didn't seem to follow the relative price level at all. But look what happened in the long run. Slowly, the two began to move together. So in the short run, we are going to need a different model to explain exchange rates. But this will explain the long run exchange rates and what we should experience in the long run. And what we know now is that relative purchasing power parity ought to hold in the long run, and that relative purchasing power parity tells us that the exchange rate or the rate of change of the exchange rate ought to equal the rate of change of the price levels. That is, it ought to equal the inflation differentials of the two countries. Now, our homework requires us to calculate this convergence, this slow convergence over time that should take place according to relative purchasing power parity. Relative purchasing power parity tells us that the exchange rate ought to start equaling the inflation differential or the changes in the price levels. So how long does this take? What's the deviation? How long should this take? Well, we find that the deviations in the exchange rate and in the inflation differentials happen at about approximately 15% per year. So the deviations die out is really a measure of the speed of this convergence that we expect to happen as a result of relative purchasing power parity. So half purchasing power parity deviation still remains after about 4 years. And we talk about this as, the 4-year half-life of purchasing power parity. So these are a rule of thumb, keep in mind, but it's a useful guide to forecasting real exchange rates. Here's a real live example. I'm just going to put this up on the board here for you to take a look at. Take a look at it closely because it gives you an example of how to calculate one of the homework assignments. In this case, we have a home basket of $100, a foreign basket of $90 in home currency, and home's real exchange rate at 0.9. So the home currency is overvalued in this case. So what is the convergence that should take place according to relative purchasing power parity? I'll let you do this as a homework assignment. Let's do a forecasting when the real exchange rate is undervalued or overvalued. So if the forecast is for the U.S. inflation to be 3% next year and European inflation is expected to be 1%, then the inflation differential is plus 2%. And this forecasts a U.S. dollar depreciation, or a rise in the exchange rate of the dollar per euro, of 2% next year. So this completes this video. I'm going to start another video discussing the main points in Chapter 3, but we're going to move on to a more detailed model. And the reason is that really all we've done so far is to explain exchange rates in terms of price levels, or depreciation and appreciation of exchange rates in terms of inflation. But the real question is where do the price levels come from, and how does inflation get determined? So in order to have a good understanding of a monetary model, we really have to understand how price levels get impacted, changed, or created within countries. And that's what we'll discuss in the next discussion lecture that summarizes Chapter 3.